The chemical properties of chlorine. We'll start by looking at the reaction with metals, the reaction with non-metals like phosphorus, sulfur, and hydrogen. Then we shall look at the reaction of chlorine with water, the formation of bleaching powder, reaction of chlorine with caustic alkalis, how does chlorine react with compounds containing hydrogen, like hydrocarbons, how chlorine reacts with ammonia, and how chlorine reacts with hydrogen sulfide. Chemical properties of chlorine. Chlorine is a very reactive element which can react with many metals, non-metals, and compounds. Most of these reactions, chlorine acts as a strong oxidizing agent, and its oxidizing number decreases from 0 to -1. Reaction with metals. Chlorine combines with most metals to give chlorides, particularly on heating. Some examples are given below. Sodium. Burning sodium continues to burn in chlorine with a golden yellow flame. Magnesium. Burning magnesium continues to burn brightly with white flame in chlorine. Iron. Hot iron reacts with dry chlorine to form anhydrous iron 3 chloride. The direct combination of elements provides a good way for preparing anhydrous iron 3 chloride, as well as anhydrous chlorides of other metals. Reactions with non-metals. Chlorine reacts with most non-metals, but does not combine directly with carbon, nitrogen, and oxygen. Phosphorus. Dry yellow or red phosphorus burns spontaneously in chlorine, giving off white fumes of phosphorus 3 chloride and phosphorus 5 chloride. Sulfur. Burning sulfur continues to burn in chlorine, and a yellow liquid disulfide chloride is formed. Hydrogen. If hydrogen burning as a jet is lowered into a jar of chlorine, the hydrogen continues to burn with a wide flame and steamy fumes of hydrogen chloride is produced. A mixture of hydrogen and chlorine explodes when exposed to a flame or bright sunlight. 4. Reaction with water. When chlorine is bubbled into water, part of the chlorine which dissolves in water reacts reversibly with water, forming hydrochloric acid and chloric acid, that is hypochlorous acid. Thus, the so-called chlorine water is in fact a yellow-green solution consisting of dissolved chlorine, water, hydrochloric acid, and hypochlorous acid, which is a very weak acid, even weaker than carbonic acid. So it exists mainly in the form of unionized molecules. From this, it is understood why chlorine water smells strongly chlorine. On exposing chlorine water to sunlight, the unstable hypochlorous acid slowly decomposes to give oxygen. Because of the above reaction, chlorine water can be used as a bleaching agent. It oxidizes dyes, thereby converting them to colorless compounds. Note that hydrochloric acid is formed whenever chlorine bleaches. So an article has to be thoroughly washed after bleaching, or it will be attacked by the free acid. Chlorine is generally used to bleach cotton, linen, and many plant fibers. 5. Bleaching powder. If chlorine is passed over moist calcium hydroxide for a considerable time, bleaching powder is formed, but is usually represented by the simplified formula. A solution of bleaching powder has similar bleaching action as chlorine water. Reaction with caustic soda. As chlorine water is acidic, it is not surprising that chlorine reacts readily with caustic alkalis. The products formed depend on the temperature at which the reaction occurs. If chlorine is passed into cold, dilute aqueous sodium hydroxide solution, sodium chloride and sodium chlorate 1, that is sodium hypochlorite, are formed. With hot concentrated sodium hydroxide solution, however, sodium chloride and sodium chlorate 5 are obtained. Note that hypochlorites are salts of hypochlorous acid, and they are extensively used as bleaching agents. Many common bleaching solutions contain sodium chlorate as the active ingredient. Reactions with compounds containing hydrogen. In fact, chlorine has such a great affinity for hydrogen that it rapidly oxidizes compounds containing hydrogen. Hydrogen chloride being produced each time. With hydrocarbons, a mixture of methane and chlorine reacts explosively in bright sunlight. Under controlled conditions, a substitution reaction occurs in which chlorine replaces some of the hydrogen atoms in the saturated hydrocarbon to produce chlorinated hydrocarbons and hydrogen chloride. For example, methane reacting with chlorine to give chloromethane and hydrogen chloride. Turpentine ignites spontaneously in chlorine with a dull red flame, producing black particles of carbon and white fumes of hydrogen chloride. A burning candle wax, petrol, consisting mainly of hydrocarbons, continues to burn in chlorine gas with a dull red flame to form hydrogen chloride fumes and black carbon. Number 8, with ammonia. Ammonia burns spontaneously in chlorine, producing nitrogen and hydrogen chloride. When all the chlorine has been used up, the flame goes out and the hydrogen chloride reacts with more ammonia to form white fumes of ammonium chloride. 9, with hydrogen sulfide. When hydrogen sulfide and chlorine are mixed, either as gases or in aqueous solutions, a yellow solid deposit of sulfur is formed as a result of the oxidation of the sulfide by chlorine. Number 10, reaction with iron 2 solution. If chlorine is bubbled through an iron 2 chloride solution, the color changes from pale green to yellow or brown. In this reaction, chlorine oxidizes iron 2 ions to iron 3 ions. Reaction with sulfurous acid. When chlorine is passed into sulfurous acid, an aqueous solution of sulfur dioxide, sulfuric acid, and hydrochloric acid are formed.